Hey math kids, today we're going to talk about the standard normal distribution. And so what that means is if we had a normal distribution and we have mu and sigma, the standard normal distribution is just n 0, 1 squared. So basically the mean is 0 and the standard deviation is 1. Okay? Now this is often denoted with a z out in front instead of an x, where in general we use an x, but when we have the standard, and where that comes from is it's called a z transformation. So we have z is equal to x minus mu over sigma. And if we want to find a z score, this is how we do it. Okay? All right. So your book talks a lot about like what a z distribution is, what z what a z score is, etc. I'll just roughly draw this. So if we have mu, which is equal to 0, and then our first standard deviation in that direction goes to -1, our next standard deviation is 1, 2, 3, etc. And so it's just kind of nice going from the left to the right. It's really easy to calculate things like that. And so, in a sense, we are normalizing things when we find this z transformation. Okay, so we're going to move on to a problem. So it says Kelly scored 73% in history, where the class mean was 68%. And the standard deviation was 10.2%. Okay, in math, she scored 66%, where the class got, or the mean was 62%. And the standard deviation was 6.8. Okay. Now, in which subject did Kelly perform better compared with the rest of her class? Assume the scores for both subjects are normally distributed. Okay, so if we're looking at history, we're going to get, once again, let me write this down. So we're using the z transformation. And so in history, she got a 73%. We subtract the mean, and then we divide that by the standard deviation. Okay. Over here, we'll do the same thing. She got 66. We take away the mean, which is 62. Then we divide that by 6.8. All right, open up our calculator. So I just need to do 73 minus 68. Divide that by 10.2. We get a 0.49. And then if we do 66 minus 62 and divide that by 6.8, we get a 56. Oh, whoops, no, that's not right. 66 minus 62, and then divide that by 6.8. Okay, so let's write down. We got a 0.49 over here. 0.490. And over here we got 0.588, I think. Yes. Okay. Now, because this score is higher than this score, she actually did better comparatively in math, even though her actual grade was lower. Okay, so 73 obviously is better than 66, but in the context of how the rest of the class did, she actually did better on math than she did on history. Okay. Now we're going to move on. It says use technology to illustrate and calculate. So we're given the probability of negative 0.41 is less than or equal to z is less than or equal to 0.67. All right, because this is a z, that tells us that we are going to use the what do you call it, the standard normal distribution. Yeah. So to do this, we're just going to remember that z gives us a normal distribution where the mean is 0 and the standard deviation is 1. So that's the notation to say that. And so on the calculator, we're going to go second, catalog. We want to go to a normal distribution. So we hit the n. And remember, because it's a range of values, not a single value, we're going to use CDF. So normal CDF. Okay. And we do the lower bound, the upper bound, and then the mean, and then the standard deviation. So our lower bound is negative 0.41, comma. Upper bound is 0.67. Our mean is 0, and our standard deviation is 1. We hit enter, and we get 0.408 if we round that. What was it again? 0.408. So once again, to draw a visual of this, we're centered at 0 now. And if we go a little bit to the left, negative 0.41, we go a little bit to the right, 0.67. The area in between those two pieces is going to be this, assuming that the total area is 1, because the total probability is 1. Okay? Now, same type of question. Z is less than or equal to 1.5. Go back to the calculator. Second, catalog, n, normal CDF. Okay, our lower bound this time is negative 99999, like negative infinity. Our upper bound is 1.5. Our mean is 0, and our standard deviation is 1. And we get 0.933. Okay, once again, what we're looking at is we're centered at 0. 1.5 is somewhere over here. We shade everything below that. And that takes up about 93% of the area, so we get a probability of 0.933. All right, one more. P of z is greater than 0.84. And we're going to do the same thing. So second, catalog, hit the N button, go to CDF, normal CDF. Okay, lower bound is 0.84. Upper bound is infinity. So we do a bunch of 9s. And then our mean is 0, standard deviation is 1. Hit enter, and we get 0.200. Okay, once again, we have this centered at 0. 0.84 is right there. And then we shade everything above that, and that's about 0.2. Okay, if you need additional help, please come to Math Lab. Until then, calculator.